Okay, so here's the code. I kept most of the licensing information about Autopsy somewhat intact in the middle. Um, then I added my parts. So these are the ones imports that I added, even though a couple of them are actually not being used right now. And this is the way I've added in the simple JSON module. This is typically how you would specify a specific method that you're making available to a program. The original documentation was saying something different, and that didn't work for me. So to show you the structure, the structure will look like this. So here's your module. This is where the location is, where we're gonna deploy the module, and simple JSON will be essentially right here. This is actually, I grabbed it from my own Python installation directory, which is which is not used by Autopsy. Autopsy has its own, and anything Autopsy does not have, you have to deploy it within this module structure. So moving on, config file, I'm hard coding it to a certain location. This is where I'm expecting to find the config file. And this is a function that I've picked up from this reference here. I modified it slightly to add depth and a file pointer. So this basically prints out the dictionary, pre-prints the dictionary for the file output that I create. This class, the factory class, is part of the Autopsy module framework. This is where you define the module names, descriptions, and so on. And the actual module class is here. There's a startup method. Here is the place that I'm actually picking up or loading up my config file, setting up all the values that I'll require later on. I am emphasizing that the API key is the one that's really more important. So right here, if the API key load fails, then I will essentially exit the module. Whereas if any of the other keys load fails, I'll simply take the defaults in the exception block. Now the process method is the key. This is where a file comes in, as our Autopsy will pass in a file, and then we can do our our virus detection work. This is from the original sample file. Any non-files, we skip the processing. I pick up the MD5 hash, which is generated by Autopsy already. If the MD5 happen to be not there, then I skip it as well. Potentially that file is either not there or not readable. Anything else, we increment the count. We also, and if it's a private API, we make a normal call. Whatever label comes back, I create an artifact on the Autopsy module. An artifact is basically ends up being one of these items. If it is not a private method, then I look for if there's any kind of number restriction from the config file, and also like if I'm telling the plugin that only process 5 files, then I'll implement it based on this if statement, and also add a pause in between the calls so that I don't get any coda error. Now let's look at this process VirusTotal API. The VirusTotal API, the first thing it'll do It'll check for the hash, whether it conforms to MD5. So far, I haven't really seen any one of them failing. Perhaps, I'm not sure if perhaps it's probably not needed. Then I set up the call to VirusTotal. Here's the API, load up the hash and the API key, make the call, get the response back. If the response code is good, that means that the call was successful. The only time it will not be successful is if there is a quota error. So whenever there's an exception that happens, I generate a quota error tag and return it. If everything went well, then start looking at inside the response. This is the simple JSON call. Normally, if that simple JSON was available in a normal fashion, I would possibly write it as simple JSON dot loads. But because the way I added it, I can call this directly like that. The mechanism that I chose to add this function. So when I get the dictionary back, this response dictionary, I look up the response code within it. The VT code, if it happened to be 1, that means the VirusTotal knows this file. And if it found any matches, it'll be in this dictionary tag, and I'll look for that match. If that match happened to be greater than 0, then I will output that information in this found hash. Notice here that I'm using a thread lock because there are 2 threads. If I write too quickly, I might get a garbled output, so I'm locking it and then writing it out and tagging it as VirusTotal detected virus. If there's no match found, then VirusTotal no match. That's what I'll do. And I don't write out this file unless the config file says I want that output on known files as well. Generally speaking, this is defaulted to no, so most of the time you're not going to see any output for these. The files could be fairly large if if you run a large image like shard or something like that. And the VT code is 0. If it is unknown to VirusTotal, then I return this tag. And at the end, during the shutdown time, we put a message out or post a message to post a message that how many files we actually processed each thread. So this is basically the code. So now let's run and show you how I will run this on the Autopsy. So let me go ahead and close this particular one. I'll go ahead and create a new case. Let's say case 10. Call it case 10. And in this particular case, I'll pick a small image, which is, I'll pick it up from assignment 7. Pick the NTFS, run this. So here's where my module shows up, and it has that description and all of that. I run it, and you'll notice how this gets populated. Now the reason this gets populated while it's running, just to show you real quick, this happens because of this call right here. So as it processes each file in this process method, it actually notifies the module data event, which essentially refreshes that count. So right here, you can see that we found VirusTotal no match, meaning these are the ones that we definitely know they're not virus, and then unknown to, these are all these files that are unknown to VirusTotal. Now let's go ahead and close this case and create another one where, so case 11, and let's go ahead and add this HFS image. Once again, let's go ahead and run this, and let's look at what it finds. So these two we're always expecting, because we'll most likely find unknown files to VirusTotal and also VirusTotal no matches. But voila, this one, we actually found one that looks like potentially there is something in it. So let's go ahead and take a look at the detail of that. And this detail can be found under C dev and found hash file. So let's take a look, and let's search for detected true. So it looks like it, out of 57, it found only one match. Now, as far as I know, I'm not really familiar with this engine. I'm not really sure how reliable this is, but at least one of them found something. So as far as I'm concerned, it found one match, and we need to be careful with this. So for my demonstration purposes, this is a good example of how a virus detected, like how many it is irrelevant. It found one match, and I'm treating it as if it's a virus. So I'm reporting it as designed. Now, going back to that case 3, it has actually found many, and those look a little bit different. So let me go ahead and just show you real quick how that looks. So here in the shard one, it found like 9 or 10 matches. Obviously, some of these name kind of indicates it potentially has some issues. So I saved off that file, case 3 found hash. Let me bring that up, and we can search for those detection true and see how it looks. So as you can see, a lot of them has, so this one, for instance, looks like an Android malware or Android adware, which is probably not as bad as many other viruses perhaps. But again, I do not know that. We probably have to look up the detail of that detection and see what kind of damage it can do, and so on. So it looks like there's another one that has only one match out of 57, but there are a few more that actually has quite a few matches. And let me find one of those right here. One of these guys, so this one, HackyXE, was identified by a number of them. eSafe, Nano Antivirus, McAfee. These are fairly well known. So this most likely looks like might be a real virus. I mean, at least identified by many engines. The other ones are, again, we have to look at the detail and see how good or bad, or how bad they can be. By the way, this is the output for that pretty print function that I showed you. It just basically goes in about one level deep. That way you can kind of line up these lines kind of in a way that's visually it's actually a little bit easier to follow. So that's basically the outputs. Now let's quickly demonstrate to you with a non-public or non-private or public API how you can see a throttling issue. So let me go ahead and bring this up, and I will switch to a public API, and I will let my module know that this is a public API, and I'm going to shorten this to about 20 seconds delay, and this will most likely will cause a throttling issue. So let me go ahead and close this guy out, and let's run a new case. Open a new case 3. 13. Finish, add a data. So I'm just going to go ahead and add FAT16. Okay. Now you're going to notice it's going to slow down significantly because now between file processing, I'm pausing about 20 seconds. So it processed 2 of them and it's waiting for 20 seconds before it picks up the next set. So this is 2 threads running essentially. So this is how you can kind of tell that 2 threads are processing, both process 1 file each, and now they're waiting for 20 seconds. And after processing about 4, it'll probably hit that 3rd, which by this time this API has already processed 4 and it hasn't been a minute yet, and it'll probably get 2 more processing, and it'll most likely get a throttling or quota error pretty soon. So let's see what happens. So as you can tell, the public API would be very difficult to run with these kinds of throttling mechanism in place. I mean, you probably can run it overnight, but if you really have a real, really large image, then this might be pretty difficult. Well, it looks like this error actually didn't occur. Let me retry and see if I can make this happen again. Maybe shorten that time even more. So let's go to virus config. So 10 seconds. That should definitely make it happen. I'm just going to go ahead and rerun it. Rerun it and run only this module only. So it's going a little bit faster, and it should get that. There you go. So here's a throttling error because we are asking for too many. We're making too many requests, within a minute, and that's why we're getting this error. So I believe that covers most of the features that I have implemented. Only other thing I haven't shown you yet is that at the end, when I was telling you that we post a message to the total, it actually shows you how many modules it found. You can see that there are 2 entries, which indicates there are 2 threads running, even though this number looks a little odd because one processed 73, another one did not. Not sure what's going on there, but generally speaking, most of the time you'll see that's evenly distributed usually. Okay, so that's all. If you have any question, please feel free to send me an email.